Today, we go over a few equipment essentials. You'll see a handful of questions on the unit test and district assessment about pieces of equipment and why you would use them. The first type of question would be the pieces of equipment that you choose for holding liquids and substances versus pieces of equipment that you'd use for measuring. If you take a look at the equipment on the left, you've got a beaker, an Erlenmeyer flask, and test tubes. These pieces of equipment have very few lines on them. If you take a look at these pieces of equipment, those lines that you see on them represent a number or a measurement. The more lines a piece of equipment has, the more accurate that piece of equipment is for reading a measurement. So because these pieces have very few lines, they're not very good for measuring accurately. So we would use these pieces of glassware or plasticware for holding liquids and substances. On the right, you'll see graduated cylinders, you'll see a pipette, and a burette. Notice that these pieces of equipment have lots and lots of lines. Remember, the more lines you have, the more specific or accurate that piece of equipment is. These are all great for measuring out specific volumes of a liquid. On this slide, you'll see a ring stand, which has a very heavy metal base with a stand. On the stand, you have different types of accessories. One accessory that we'll use is a ring. You can place a wire gauze on top of the ring, and that ring can hold up very heavy glassware. For something like heating, we can put a Bunsen burner under the ring, and it can heat a substance above it. What we'll use most frequently is called a utility clamp. You screw in the utility clamp on the stand itself, and then it has a little arm, and you can suspend different pieces of glassware like a pipette or burette or a thermometer using that clamp, as you'll see on the left-hand side of the picture. You're going to become very, very good at reading a graduated cylinder. You'll have several questions about how to read a graduated cylinder. And the first and most important thing that I'll want you to consider is those number of lines again. Remember, each line stands for a number. That number stands for a measurement. So the more lines a graduated cylinder has, the more accurate it's going to be. When you're measuring out a specific quantity of a liquid, always place that graduated cylinder or any piece of glassware or plasticware for that matter on a flat surface, and then you'll bend over and read that measurement at eye level. So let's consider, for example, I ask you to measure 2.5 milliliters of a liquid. If you look at a 10 milliliter graduated cylinder and say a 50 milliliter graduated cylinder, I want you to compare the number of lines. Not only the number of lines, but I also want you to consider what each line stands for. And a 10 milliliter graduated cylinder, each line stands for 0.1 milliliters. And a 50 milliliter graduated cylinder, each line stands for 1 milliliter. So if I ask you to measure out 2.5 milliliters of a liquid, out of the two, which one would you be able to give me 2.5 milliliters more accurately? Hopefully you've chosen the 10 milliliter graduated cylinder, and you'll get tons of practice with this throughout the year. Number 3, always read the measurement at the bottom of the meniscus, or curved line. Some liquids, such as water, can stick to the sides of glassware or plasticware, and they'll give you that curved line. So if you look at the red dotted line, that shows you the bottom of the meniscus. Always read at the very bottom, forget about the top of that curve. Number 4, every measurement has a degree of certainty and uncertainty. When recording a measurement, scientists across the world agree to report all certain digits plus the first uncertain digit. So before we go any further, it's important to understand what a certain digit is and what an uncertain digit is. Simply put, a certain digit is any number represented by a line on a piece of equipment or glassware. An uncertain digit is any space in between two lines on a piece of equipment. So if I look at the pictures down below, my certain digits are any line on the graduated cylinder. So in between the number 30 and 40, you see those little dashes or hash marks? Those are all certain digits. I know with certainty that those represent the number 30, 31, 32, 33, all the way to the number 40. I also know with certainty, if I look at the picture to the right with the blue liquid inside, each line also stands for 1 milliliter. So if I read right above the number 35, that's 36 milliliters. The next line is 37 milliliters. Those are all certain digits. An uncertain digit is any space in between two lines on a piece of equipment or a graduated cylinder. So if you take a look at that blue liquid again, notice that it's in between two lines. That would be an uncertain digit. So when I report this measurement, I'm going to report all certain digits. I know with certainty that this falls at least at 36 milliliters. The uncertain digit is what comes after that 36. Is it 36.2, 36.4, 36.5, 36.7? And really it's in the eye of the measurer what you think that uncertain digit is. So certain digits are numbers on a piece of equipment. Uncertain digits are any space in between those lines on a piece of equipment. And last tip, because you'll see this question on your test, unit test and district assessment, should your liquid fall right on the line like it does on the graduated cylinder outlined in orange, your uncertain digit is at 0.0. So I know with certainty that it's 35 milliliters. So when I report the uncertain digit, if it does happen to fall right on the line, your uncertain digit is always going to be a 0. Keep that in mind, you'll see it again. You'll also be asked to record the mass of various different substances. You'll use a digital scale like you see in the picture on the screen. Number 1, make sure that it's plugged in. If the numbers don't come on the screen, try to wiggle the power cord in the back. Just ensure that it's plugged in correctly. When the scale reads 0.00, then you're ready to start recording your mass. Some students want to put something on the scale right away before it's been zeroed out, and you're not going to get an accurate reading. It's probably going to tell you ERR or error. Powders, granules, pellets, liquids, these small things can't be placed directly on this scale. And you'll want to keep this in mind. You've got a lab coming up later this week where you're going to have to use this little clue or tip. So if I have something that I can't place directly on the scale because it'll either fall off or it needs a container to hold everything together, I'm going to place whatever the holding container is, the empty holding container, I'm going to place on the scale first. You have small medicine cups that you're going to use throughout the year to hold different things like those powders and pellets and liquids. So the first thing you're going to do is place that medicine cup directly on your digital scale. Next, you're going to see an on-off button on the left-hand side of your scale, and you're going to press that. That's going to zero out your scale. So even though you have your medicine cup sitting there on top of the scale, it's currently reading the total mass as 0. Now you're going to place your substance inside that medicine cup and you're going to read the mass. So there's no need to subtract the mass of the container because you've already zeroed out your scale. This is a nifty little trick to reduce some of the math that you have to do. So one more time, if you have to measure the mass of a small substance that can't be put on the scale directly, the first thing you do is place the medicine cup on the scale. Press the on button again. It will zero it out. Make sure that the scale reads 0.00 at the bottom. Then you're going to add your substance to the medicine cup and you'll record the reading exactly as it is. Every once in a while, you're going to have a substance that's already in a holding container and you won't get the luxury of taking the mass of the container ahead of time. Well, no big deal. You can take the mass of the container with the substance inside, record the total mass. Then once you use your substance or empty it out, you're going to use that empty holding container, whether it be a beaker or that small medicine cup that you're going to use throughout the year, and you're going to take the mass of the container only and record. To determine the mass of just the substance alone, you're going to take the container plus the substance, which in the example below is 15 grams. Then I'm going to subtract the mass of the container. If the mass of the container was 1.2 grams, the remaining mass, after I subtract that 1.2, which would be 13.8 grams, that's going to be the mass of my substance only. Determining volume. So first off, volume is the amount of space that a substance takes up. We're going to use this definition, again for our lab that you'll complete on Thursday. If I have a regularly shaped object like the cube you see in red, I'm simply going to do length times width times height. I'm going to use a ruler, I'm going to take my measurements, multiply, and get my volume. If I have a liquid, I'm going to use that graduated cylinder or a pipette or a burette to get the measurement for my volume. If I have an irregularly shaped object, like say this dinosaur, I'm going to use a water displacement method. So notice that the graduated cylinder currently has 4.8 milliliters of water without the dinosaur. You're going to dump the dinosaur in. My new reading is 5.24, so 5.6 milliliters of water. So to find the volume of just the dinosaur alone, I'm going to take that 5.6 and I'm going to subtract the 4.8 milliliters that I had originally, and the difference between the two is going to be the volume of the dinosaur. You've done this method before in middle school, so it shouldn't be anything brand new for you. So 3 ways to determine volume: length times width times height, use a graduated cylinder and just read the volume of a liquid, or the water displacement method. And last but certainly not least, what is density? Density is how heavy something is compared to the amount of space that it takes up. So I want you to write down the formula for density. Density is equal to mass divided by volume. And then I want you to consider the brick and the loaf of bread below. Let's assign some phony numbers and try to calculate the density of the brick and the loaf of bread. First off, let's give them the same volume. I know they probably don't have the same volume in real life, but for today's example they do. We're going to give them a nice easy number to work with, and we're going to say that they have a volume of 10 centimeters cubed. Their mass. Let's say the mass of the brick is 50 grams, which again is not correct, but just for math's sake. The brick has a mass of 50 grams, and the loaf of bread has a mass of 10 grams. So plug in those numbers for density. Mass divided by volume. What is the density of the brick? 50 divided by 10 is 5. So the density of the brick is 5 grams per centimeter cubed. What about the density of the loaf of bread? Well, if the loaf of bread had a mass of 10 grams and I divided it by a volume of 10 centimeters cubed, its density would be 1 gram per centimeter cubed. So if I compare the densities, the density of the brick, 5, the density of the bread, 1, which one has a higher density? And we're going to roll with the brick.